This segment is an introduction to vector quantities. Vectors are a concept used in science and math, in the field of physics and engineering, structural design, navigation, flight, also boating. What we're going to learn to do here is we're going to learn to draw a vector and then add vectors by a sketch and then subtract vectors by a sketch. But first I'd like to explain to you that vectors are quantities that are only fully described if you give me both magnitude and direction. So for example, let's say that a plane is flying at 450 miles per hour. And I'm going to draw a vector representing this. 450 miles per hour. That's not enough information. You have to tell me if it's flying in an easterly direction, a northeasterly direction. You need to tell me if it's maybe, so let's say this is east, here's north, south, west. You need to tell me the angle it's flying at. So maybe this is a 25-degree angle. So you might say the plane is flying 450 miles per hour at an angle of 25 degrees north of east. So magnitude is the numerical value about the length of the vector, and direction is the angle with regards to either north, south, east, west, or the rectangular coordinate system. What we're going to do is we're going to learn how to implicate or add wind to that. So let's say wind was a vector that was coming out of the southeast and wanting to push this plane. This plane would get pushed that way, and its actual travel would be something like this. So the pilot has to plan for that and add these two vectors. The pilot's got to add the wind vector into the speed to account for it and make sure that they land at the proper spot and airport. What we're going to do first is we're going to do a little bit of drawing. So this is vector A. Sometimes in a textbook they'll put an arrowhead over the top of it to represent the vector. This is called the tail of the vector, and this is called the head of the vector. And if I want to add or subtract, for that matter, two vectors, I can draw them as a scale drawing, so in AutoCAD, SolidWorks, whatever, with paper and pencil. And if I want to add vectors A and vectors B, I will draw vector A in the length that it was given, approximately. I'm just doing a sketch here. And I will add to, I got to put the arrowhead. So here's vector A. To add vector B to it, I've got to take the tail of vector B and put it to the head of vector A. And I've got to try to draw it at this slant right here and at that length. So there's vector B, approximately. Again, vector B. And let's put the arrowhead on it. So this is like, you know, it's not feasible because the wind is not that strong, but if the plane was traveling like this and the wind was coming out of the southwest and wanting to push it, then the plane will actually travel from the tail of the first to the head of the last. Because of the pushing of that wind, that's the resultant vector. Sometimes I'll put a double stroke R there to show a resultant vector. The red line is the answer to my problem. I'm trying to add these two vectors. Plane and wind results in this movement. So number 2 says add C and E. So I've got to scroll up for you to see number 2. This is going to be hard, so you're going to have to use your own document. So C, I believe, goes down like this, and I believe E goes like this. So here's vector C plus vector E, and the resultant, or the answer of these two, is from the tail of the first to the head of the last. I'm just trying to draw a sketch. I want you to know that you can add in any order. So see number 3 here, it says add vectors B, D, and A. Well, I want you to know you could add D, A, and B, because addition is a commutative process. So it doesn't matter which vector you go for first. So I'm going to go ahead and take a peek at what these vectors look like. So D goes like this, B goes like this, A goes like this. I'm trying to memorize it in my head. So D, I'm going to start with D. So I'm going to draw, because I wrote it right here. So D goes like that, as I recall, and it's about that long. I'm going to redo it. So D is here, And then as I recall, vector A goes this way from a previous problem, and it's about this length. And so again, I'm adding D first, then vector A, and then as I recall, B goes something like this. So I'm going to add the tail of B to the head of A. So you can add 3 or more vectors. I believe vector B was about that long. And then the resultant is always from the tail of the first to the head of the last. So that would be kind of like a ship navigating in the ocean. So the ship's trying to go like this, the wind is pushing it like this, the water current is going like this, and this is what actually happens to the ship. This is where it actually goes. Let's just do a few more problems. Let's get some subtraction and some multiples. So let's add vector A and 2 of vector D's. So 2 of them, it's just a multiple. So vector A is about this long. I'm going to go ahead and keep that in red. And then vector D goes like this, but if I want to add 2 of them, then I'm just going to go ahead and add 1. And I'm going to put the arrowhead on. And 2. And I'm going to put the arrowhead on, and the result of that is from the tail of the first to the head of the last. So that's, again, that's the answer. This is done by what's called the Polygon Method. I'm going to show you how to do this by the parallelogram method in the next segment, but I think I want to just do one subtraction problem before we stop. So if I want to take A and subtract D, then what I need to do is I need to take A and add the opposite of D, because in algebra we know that subtracting means to add the opposite. So when I go to draw A and then D, D normally goes like this, going downward and to the right. I'm going to draw it this way with the arrowhead going that way. So I'm going to start with A, which is this way. So I'll draw vector A, and I've done this unusually because now D normally goes like this. I've got to go backwards with it, adding a negative D, so it's going to get into my problem is all. And I've got to go peek at the angle of D just so I can remember. Oh yeah. All right, so the angle of D is a little bit like this. And again, remember you put the tail of D to the head of A. This was A, and then I added the opposite of D, and the result of this is from the tail of the first to the head of the last. In this section, in Chapter 9, Section 1, we're just drawing sketches and scale drawings in order to get a feel for what would happen with the sum of multiple vectors. I'm going to stop here, and next segment we're going to introduce this by the parallelogram method. Still the same answers, but a different method.